We've got a word problem here. In fact, this is a work problem. So what we know is this. Person A, working alone, can complete a job in 4 hours. So it takes person A 4 hours to do this job. Person B, working alone, can complete that same job in 8 hours. So it takes B 8 hours to do that job. And if they work together, how long will it take them? Well, we do know this, that person A by him or herself can do it in 4 hours. So if he's getting help from B, it's going to take less than 4 hours. So what we want to know is how long will it take them together to complete the job. So why don't we introduce a variable? Let's let x equal the amount of time, how about AMT, the amount of time working together to complete the job. All right, so x is going to be how long it takes to complete the job when they're working together. Now, here's how I'm going to set this up. Person A takes 4 hours to complete the job, so I'm going to draw a little picture here. I'll draw it over here on the right. So suppose it takes person A 4 hours, so this is 4 hours, to complete the entire job. So I want to reduce everything just to 1 hour. So in 1 hour, right, if we just do 1 hour, this is 1/4, right? So what I mean is this. It takes person A 4 hours to do the entire job. In 1 hour, person A can do 1/4 of the job. So person A's contribution will be 1/4. So I'm going to write, here's the contribution in 1 hour. Person A can complete 1/4 of the job in 1 hour. Now, person A is getting help from person B, and person B, well, person B takes 8 hours. So I'm thinking of it this way. Here's B. Person B takes 8 hours to do that job. So in 1 hour, right, that's just a 1 hour, person B can complete 1/8 of the job. So B's contribution will be 1/8. In 1 hour, person A can do 1/4 of the job, getting help from person B, and in 1 hour, person B can do 1/8 of the job, and together, this is together, in 1 hour, they can complete, now this looks a little strange, or it might sound strange, they can complete 1/x of the job. Let's just track over what we did here. In 1 hour, person A contributes 1/4 of the job. In 1 hour, B contributes 1/8 of the job. Now it takes X hours altogether, right? So if we look at it all together here, it takes X hours to do the entire job. So in 1 hour, together, like blended as one person, they can do 1/x of the job. So 1/4 plus 1/8 of the job is 1/x. We can solve this. Here's the LCD. In this case, the LCD is 8x. Multiply every single term up here by 8x. So I'm going to put the 8x here, the 8x here, and the 8x here. Doing so will give us, see if we can get it to right, 8x dot 1/4 plus 8x dot 1/8 equals 8x dot 1/x, right? So I got that LCD here, here, and here in front of every one of the originals. And now 4 will go into 8 twice, so we're left with 2x times 1, 2x, plus this 8 here will cancel with that one, and we're left with 1 times x, just x, equals, now this x, get it here, this x cancels with that x, and we're left with 1 times 8, which is 8. So now we've got, okay, over here, we've got 3x equals 8, and divide by 3. I'll do it right up here. This will give us x equals 8/3. And because we're dealing with time, I'm going to write this like this. I'm going to write it as 3 will go into 8 twice with the 2 remainders, so about, what do you think here? 2/3? So we're going to conclude then that working together is going to take them 2 2/3 hours to complete this job. Now this problem here is similar to 35, except we have a drain which is working against us. So what we're going to do is kind of what we did before, is we're going to let x equal the amount, AMT, the amount of time working together to fill the tank. Now, pipe A by itself can fill the tank in 4 hours. So I'll draw that little picture like we did last time. All right, here's over here on the right. So pipe A can fill the whole tank in 4 hours. So in 1 hour, pipe A can fill 1/4 of the tank. Right, so A's contribution to the filling the tank will be 1/4 plus. Now B, that can fill the tank in 10 hours. So I'll draw that picture here, over here on the right. So here's B, that takes 10 hours. So in 1 hour, B can fill 1/10 of the tank. Right, so let's write that over here. So B's contribution would be 1/10. Now, pipe C, this is a drain, so this is working against us. So what we're going to have here is a minus. Now pipe C, this takes 20 hours to drain the tank. So if we draw our picture over here, here's pipe C. It takes 20 hours by itself to drain the tank. So in 1 hour, it can drain 1/20th of the tank. It can do 1/20th of the job. So this contribution for the drain pipe is going to be 1/20. Now what we have is all of this right here. This is the individual contributions, and that's all together. So that's all of these pipes working together, and that's got to equal now 1/, this is going to be the same form that we had, 1/4, 1/10, 1/20. This is going to be 1/x, and that should make sense because working together, if you take all of these things together as one, say one big pipe, it takes X hours. So in 1 hour, it can fill, or actually, fill 1/x of the tank. So this is our equation now. And all we have to do is solve this, getting the LCD, which is, so the LCD here is, how about 20x, right? 4, 10, and 20 all go into 20, and then the x. So there's our LCD. So we know what to do. Write the LCD here, 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 and here. Write the LCD in front of every one of the original 4 terms. So it's going to look like this. 20x times 1/4 plus 20x times 1/10 minus 20x times 1/20 equals 20x dot 1/x. And now all these denominators should cancel. So what happens in this first term? The 4 goes into the 20, right? So 4 goes into 20 5 times, and we are left with 5x times 1, 5x, plus, now here in the second term, 10 will go into 20 twice, so let's cancel that. 10 will go into 20 twice, and we are left with 2x times 1, 2x, minus, now in the third term, the 20s are going to cancel. Let's do that. 20 into 20 is a 1, and we're left with then 1 times x, which is just the x. And then the whole thing here is equal to, now in the last term here, this x will cancel with that one. Let's do that. That x cancels with that one, and we're just left with 1 times 20, which is 20. And that should have been a blue one. Okay. Oh, I got colors mixed up. Well, that's all right. Let's just keep moving here. So let's add up these x's. We got 5 of them, and 2 of them is 7. Minus 1 is 6 x's. So we got 6 x's. That's equal to 20. Divide by that 6. We'll get x equals 20/6. Let's reduce. How about 10/3, which turns out to be 3, and it'll go into 10 3 times, with 1 left over. So let's conclude now that we can fill up all of these, we can fill up the tank with all these pipes open in 3 1/3 hours.